Hi and welcome back. So in this video, what we're going to start talking about is we're going to start talking a little bit, I guess, about the reactivity of different elements. And if you remember from a past video, we had kind of gone over some names of different groups on the periodic table. And I had kind of talked a little bit about which ones are reactive, which ones are the most reactive, which ones are non-reactive, as in the case of the noble gases. And what we're going to talk about in this video is essentially the part of the atom that determines how something, how elements and atoms react with each other, and how different whether or not different parts of the atom are shared or else completely transferred. And essentially what we're going to do, or to demonstrate that, we are going to again take a look at, if you remember these diagrams, actually I think I only showed one of these diagrams in a previous video. And if you remember in that previous video, I had said to think of one of these diagrams as what a helium atom would look like. In this video, what we're going to do instead is we're actually going to consider these to be, you should think of these as being, or imagine these to be something that more like what a hydrogen atom would look like. So more like what a hydrogen atom is. And you might not even necessarily know what the difference between a helium and hydrogen atom is, and that's perfectly fine. I'm pretty much saying that these two different atoms that we're going to draw are going to be hydrogen atoms because we're going to essentially make them react, or to try to imagine what they would look like when they react. And if you remember from a previous video, helium is part of the noble gases group on the periodic table. So helium really is going to be very non-reactive. It's not going to, and here comes that word, it's not going to want to react. So what we're going to, I guess, talk about is we're going to look at these two atoms, and they're really going to look the same as, pretty much the same as when we drew our helium atom. So you can remember that we have our nucleus that's going to be 1/10,000th of the size of the entire atom, and it's just going to be the point really close into the center. And for hydrogen, remember hydrogen's atomic mass is 1.0079 atomic mass units. So this means, and I forget exactly the figure, but the vast majority of hydrogen atoms actually have no neutrons. Only, I think it's 0.015%. I think it's 0.015%. And don't, I mentioned exactly what the percent abundance is in a previous video, so don't memorize this figure, but I think it's 0.015% of all of the hydrogen that you find in nature is what's known as deuterium, which is essentially a hydrogen atom that has both a neutron and a proton in the nucleus. It has one neutron and one proton. But the vast majority of hydrogen atoms, what is in the nucleus is just one proton. So I'll go ahead and write that in for both of these. And that's what we're going to imagine this is. We're just going to say that we've got one proton in each of these nuclei. So we're not even going to worry about neutrons at all for this video. And if you remember, so we're looking at a neutral atom. So if we remember our probability function about where we might find an electron, is going to be essentially this whole area, and where we have darker shades of gray and black, that's a higher probability of finding an electron there. So as we get closer in towards the nucleus, we've got a higher probability of finding our electron than as we move out from the nucleus. But still, about this radius is going to be most of the probability. It's not 100% of the probability of where we could find an electron, but it's going to be most of the probability of where we can find an electron. And then this is our other hydrogen atom, and again, this whole boundary is going to be most of the space where we might find our one electron in this hydrogen atom. So essentially, we've got here two different hydrogen atoms. And now let me ask you something. If these two atoms were going to react, what part of the atom is going to react? Is it going to be, are we going to somehow, is the nucleus, this positively charged nucleus, somehow going to react with this positively charged nucleus, or are we going to have some interaction between these two 10,000 times larger electron clouds? And you can probably imagine we're going to have some type of interaction between these electrons. But essentially, I'm not trying to downplay the importance of the nucleus in these reactions, because the nucleus, obviously, that's the positive charge on the nucleus is the attractive force that's keeping this electron in this orbital, that's keeping this electron around the atom. But essentially, what is going to determine how reactive an element is, and here comes that word again, how much an element wants to react, is going to be the electron configuration, or essentially how many electrons we have around an atom, and specifically, and we're going to start getting into this over the next couple of videos, what the shape of these orbitals is around our atom. So let's just write that down. Essentially, what I'm trying to say in this video is that the electrons determine the reactivity of whether or not, we talked about how the noble gases don't want to react. We talked about how these elements, the noble gases, don't want to react, or you could say that they're already at a low state of potential energy, and they to react would increase their potential energy, so therefore they don't react, or they don't want to react. The reason, and we're going to get into the specifics of why this is in the next couple of videos, but the reason is because of their electron configuration. And I guess to start off, this is, if you're in a chemistry class right now, one of the things that I really appreciated about, and I know I keep mentioning this in all of the videos I do, I keep bringing this up again and again and again, but one of the things that I really appreciated about the Khan Academy is that essentially this is where, talking about electron configurations and what shapes and pretty much how electrons are distributed within atoms, this is exactly where the Khan Academy's chemistry playlist starts, more or less. Now, I'm trying to still fit this in towards the beginning of my playlist. It's definitely coming way before it was. This was actually the last thing that we covered in my chemistry class. And I guess it's one of the things that I feel I can improve a little bit online, is to talk about the electron configuration towards the front of I guess my chemistry playlist, the same way that the Khan Academy does, because 90% of this course, or most of what we are going to be talking about, is how reactive different compounds are, or different molecules or different elements on the periodic table, and exactly what certain elements like to react, and how they like to react. And all of that is determined by the electrons, about how the electrons look, how many electrons are around an atom, specifically how many electrons can be around an atom. One of the things we're going to be learning a lot about in the next bunch of videos is how essentially hydrogen only has one electron around it. So, or I could say normally hydrogen only has one electron around it. So it makes a little bit of sense that a hydrogen atom can't necessarily fit as many electrons as let's say I don't know, gallium. It makes sense that there is some I guess more or less, I don't want to say limit, but you know, there is some trait about a hydrogen atom which prevents it from having as many electrons around it as gallium. And I guess, you know, you could say that you know, that trait is probably because there's only one proton in the nucleus and there's only so much attractive force for that electron to stay around that nucleus. But still, essentially, the point I want to get across here is that the electrons and the electron configuration is going to completely determine how reactive different elements are. And this is essentially what the rest of our course is about how reactive different things are. Therefore, we're going to cover, you know, there are numerous different ways to cover, I guess, electron configurations. For this, I'm going to give you at least an introduction to electron configurations and how to write out electron configurations, because I felt that it's when I started looking at the Khan Academy's resources and they started with electron configuration, it was immensely helpful for me going through my chemistry class. So anyway, in the next video, I am going to start talking about electron configurations and the orbitals which electrons go into. So thanks for watching, and I'll see you in the next video.